So today we're going to go ahead and move into motion in more than one directions. Now we're not going to get super complicated with our motion. We're going to go from one direction now to two directions. So far we've done horizontal motion and vertical motion, which we call free fall, and now we're going to mix those two. Keep in mind something going down a ramp is only one direction. Even though it's kind of going down and kind of going across, we can treat it like it is just one direction. And so really what we're looking at now is what will be projectile motion, or some kind of object trying to move in a straight line, but maybe with another force acting on it, or a combination of forces acting on it. And we've already had the first two terms here, and so you shouldn't need to jot those down again, but just a quick reminder, a scalar is any quantity that has just a unit. It has just a magnitude, just a size. It does not have a direction. Scalar quantities include temperature, speed, and so on, but there's no direction with them. Most of the quantities we use in physics are vector quantities. They have a magnitude or size and also a direction that goes with them. This is velocity, this is acceleration, forces. They have a magnitude and a direction. And what happens is when you have more than one vector working at the same time, let's say when we throw an object, we have gravity working on it in the up and down, and we have our initial push working in the horizontal or maybe at some angle up and down even as well. And so then we end up with two vectors working on the object at the same time. And so then when we consider both those vectors together, we get a resultant. Resultant is just a fancy math term for the geometric sum of two vectors. Instead, what we may have, though, is an object where we just know the properties here, and the math along this angle gets complicated and ugly because gravity works in the up and down, and the original throw maybe was in the horizontal, or maybe it was at an angle. But either way you go, the math here gets ugly. And so instead what we do is we break it down into its components, into the up and down and the left and right, or horizontal, the vertical and the horizontal. And when we take a vector and separate it into its components like that, that's called a resolution. Again, those are both math terms. They really come from calculus, but we can deal with vectors without calculus, fortunately. So we need to review some trigonometry. You've had some trig in your math classes, even if you've not taken trigonometry as a separate class. But the first one, and the one you probably were first introduced to, was Pythagorean theorem. And you can put Pythagorean theorem on your formula page if you insist. You can even include the diagram here if you'd like. Though hopefully you have this one memorized. But Pythagorean theorem simply says that when we know two sides of a triangle, we can calculate for the third if it's a right triangle. And keep in mind, these are all squared, so if we want to solve for c, c is really equal to the square root of a squared plus b squared, and make sure you pay attention to order of operations there when you do this. The other thing we need to review is sine, cosine, and tangent. And so when we have, again, a right triangle, we can figure out the angles involved using the sides, or use the angles to figure out the lengths of the sides. And so if we're looking at this angle here, for example, and frequently we abbreviate angles with a Greek letter theta, over here would be the opposite angle, or opposite side, excuse me, and here's the adjacent side. And so, depending on which of these we know, we either use sine, cosine, or tangent to solve for it. But it's really the sine of the angle is equal to opposite over hypotenuse, for example. And so if we want to solve for the angle, which is what we'll do more frequently, we end up doing the inverse sine, and there is a sign to the 1 minus button on your calculation. Usually it's the second function of the sine button of those two side lengths. But we can also, if we know the angle and know one side, we can figure out another side. And of course, depending on what we're wanting to solve for, we could use sine, cosine, or tangent. Most often, we will use tangent. It'll be our most common trig function that we use. And we'll do some examples of basic trig calculations, as well as then applying them to vector calculations next time in class.